So we've seen already that we can do both of these transformations together. And in the colored box on yours, or in the shaded box on yours, again, I'm going to get you to rewrite this with the plus k on the right-hand side, because that's more how we're going to look at things. So this equation that they've done in blue, we can rewrite this one as well. And so if you have a graph to begin with, what's happened to the red graph? Can you see that the red graph has been moved 2 to the right and 4 units up? You can have both of those translations happen at the same time. Now, how does that equation show up? Well, the 2 to the right has to happen inside the function, and the 4 up has to happen outside the function. So in this case, with the blue graph, the 2 to the right shows up as x minus 2 inside the function that's getting to the power of 4. And then the plus 4 shows up afterwards. This is where function notation can be really helpful. Let's say we weren't given these equations at all. We didn't know that that graph was negative x to the 4. Probably you've never seen negative x to the 4 in your life. It looks like a negative parabola, doesn't it? It's just a little bit wider at the top than a negative x squared graph. But if we had never seen this before, we could still do this question in function notation. And in function notation, we would say, let's say my original graph is just some function which I don't know the equation, y equals f of x. That's just generalizing it. It's some function. What do we do to that function in the blue one? In the blue one, we've moved it 2 to the right and 4 up. So if I wanted to write the blue one in function notation, I would write, well, 2 to the right happens inside the function. So in function notation, I would say f of x minus 2. That's inside the function. And then up 4 happens outside of the function. That would be plus 4. If we think about the function notation, that can also help us write the actual equation if we know what the actual equation was. So we knew that the original red equation was negative x to the 4. If instead of an x inside our function, we have an x minus 2, can you see in the blue equation that instead of having negative x to the 4, we have negative bracket x minus 2 to the 4. The x was replaced with an x minus 2. And then in function notation, we have a plus 4 outside of the function. And in our actual equation, we have a plus 4 outside or after as well. This movement between function notation and the other equation is called the explicit equation. Takes some practice. But it's good to be able to work with both. So now we can go to our second example. It's given to us in function notation, j of x. We don't know what the equation of this actual graph is yet. Sketch the image of the graph after translation of 4 units left and 5 units down. Write the equation in terms of the function j and state the domain and range of each, the original one and the one after. So moving it 4 to the left and 5 down, what I would do is I would choose some key points. It looks like those 3 would be very key points to use. I'd move it 4 to the left, 1, 2, 3, 4 to the left, and 5 down. 1, 2, 3, 4, 5. 1, 2, 3, 4 to the left. 1, 2, 3, 4, 5 down. And 1, 2, 3, 4 to the left, and 5 down. Get those 3 new points, and then draw the graph in the same shape. Put arrowheads on the graph to show that it continues. You'll notice in your textbook with the graphing software that they used, whenever their graph hits the edge, they mean for it to keep going, but they don't have arrowheads on it. So if you're really fussy about things, you might want to even add arrowheads to the original graph. So now we've sketched the graph after the translation. We want to write the equation in terms of the function j. So we're getting this same language as we had before. I highlighted it. Apparently, the computer is not very fast today. There it is, in terms of reacting. So in terms of the function j, so now I want to write y equals. It says equation. Equation always has an equal sign and something on both sides. Every time you see the word equation, you need an equal sign and something on both sides. I talked about errors. If you don't write it as an equation, you will get an E2 error. So an equation in terms of the function j, well, I moved it 4 to the left. That would happen inside my function. I'd write plus 4 because everything in the inside is opposite. And then I moved it 5 down. That 5 down shows up outside or after the function as minus 5. That's in terms of the function j because I have the function j on the right-hand side of my equation. Domain and range. For our original graph, in set notation, domain are my x values. Because there's arrows on the end of my graph, we assume that it continues forever to the left and forever to the right, which would be all the x values. In set notation, you might remember writing this as x is the element of the reals, but most people just say xer. But you have a fancy e and a fancy r. That means all numbers are possible. In interval notation, you would start at negative infinity and go to infinity. And we use round brackets in English because you can't really include infinity. Our range for our graph here, our y values, we do have a minimum y value on our red graph is 0, but it goes up forever. So we would write that as y is bigger than or equal to 0. In interval notation, we'd use a square bracket for 0 because it's included, and it goes up forever, so it goes to infinity. Similarly, we can do our domain and range for our blue graph. Again, our domain is everything. Our domain are our x values, and what affects our x values is moving left and right. But if you had everything, and you move left or right, you still have everything. Our range are our y values. Our y values are affected by moving up and down. And now our range was y is bigger than or equal to 0, but we've moved down 5. And now our range is y is bigger than or equal to negative 5, or negative 5 to infinity. So again, we reread the question quickly. We've sketched the image graph. We've written down the equation in terms of the function j. We've stated the domain and range of each question, so we've done everything we needed. questions for practice are 8, 9, and 10.